Hey everyone. Okay, so we only have the last part of this left, and it's solving rational equations. This is something, again, that you've been introduced to last year, but let's go over what it's all about. So to solve a rational function, basically what you need to do is multiply each term in the equation by the LCD, the least common denominator of all the terms of the equation, right? And then you have to make sure to check for extraneous solutions, okay? Because rational functions, if there is an expression in the denominator, then there is a possibility of you getting a value that will make the denominator zero. So you have to watch out for that. Okay, so let's solve the following functions stating any restrictions. Restrictions are exactly what I was just talking about, values where the denominator equals zero. Okay, so take a look at this equation here. We have x minus 4 over x minus 6. And now we know that since x minus 6 is in the denominator, x can never be 6. This is a restriction, okay? X can't be 6 is a restriction. So if this is x over 1, the common denominator between the 1 and the x minus 6 is x minus 6. And so we multiply every single term by x minus 6, even the 0, okay? For technicality's sake. So here, we're going to get x times x minus 6. The x minus 6 is canceled there, so minus 4 equals 0. And now look, it's just an algebraic equation. X squared minus 6x minus 4 equals 0. Sadly, we can't factor that one. So quadratic formula to the rescue. 36 minus 4 times negative 4 all over 2a. 6 plus or minus, this here we're going to have, I'm sorry, this was a minus. So 36 plus 12, 36 plus 16, that'll be 52 all over 2. So that will be 6 plus or minus 2 root 13 over 2, and then simplifying, I get 3 plus or minus root 13. Okay, none of these are a restriction, so those are both solutions to this. All right, let's move on. So here we have a more complicated setup. You see here you've got a polynomial, which it's best to factor. Okay, so now what are the restrictions? Well, x can't be negative 3 and x can't be positive 6. All right, and what's the LCD? The LCD is x plus 3, x minus 6, right? Common denominator of all of them. So let's multiply that in red. X plus 3, x minus 6. So I'm going to multiply each of the terms by it. Okay, so let's see what cancels. The first term, the x plus 3's will go away. Then the x minus 6's, then they both go away. Here's where you have to be super careful, because if you're not meticulous in keeping track of things, then you'll have missing or extra terms everywhere. Okay, so here we got 2x, x minus 6, plus 3 times x plus 3, equal to 27, distributing 2x squared minus 12x plus 3x plus 9 equals 27. Let's bring everything to the same side and simplify. So 2x squared minus 9x minus 18 is equal to 0. Okay, so we're going to factor this. All right, so how do we get 2x squared? By multiplying 2x times x. And now what we need is we need two numbers with a product of negative 18 but when we do the outer and inner of the foil, we have to get -9, right? So how do we get -18? Well, 3 and 6 is an option. And so it turns out to be +3 minus 6. So what do we get here? From this term, 2x plus 3 equals 0. X is -3/2. And here, x is equal to 6. But remember, that's a restriction. So the only answer is -3/2. So again, you can get one answer, 0, if they're both the same as the restrictions. There is no requirement on the number of solutions you should get. Okay, let's do an application problem. So this here is in physics, the lens equation. Basically, if you have an image through a lens, if you're looking at something through a lens, this tells you, where something will focus and so on. So where do we have a lens that has to create an image from an object that it's looking at? Yep, in your eye, right? So in your eye, if you look at an object, the lens in your eyeball, it creates an image in the back of your head. And so if that is out of focus, basically, that's when you need glasses because everything is blurry, right? So this is the equation by which all of that works. It's actually fascinating. All right, so in this equation, we've got f, di, do. What do all these mean? Well, f is what we call focal length. Di is the distance from the lens to the image. Do, distance from the lens to the object. Okay, so suppose the image is 10 centimeters from the lens. Well, that's di. And suppose the focal length is 6 centimeters, that's f. Write a rational equation to model the situation. Well, it's pretty basic. You pretty much just plug these into that formula. So it's 1 over f equals 1 over di plus 1 over do. So that's 1 over 6 equals 1 over 10 plus 1 over do. That's it. Okay? And now it says find the length from the lens to the object. So basically you need to solve that equation for do. Okay, so what was this equation? I have 1 over 6, 1 over 10 plus 1 over do. We're going to do the same exact thing. What is the common denominator between the 6 and the 10? 30. And then the do as well. So it's 30 do. So we're going to multiply everything by 30 do. Okay, so what do we get? 5 do equals 3 do plus 30. Bring the 3 do to the left side. 2 do is 30. And do is 15. So it's 15 centimeters. Okay, and that's all. All right, thank you for listening. Have a wonderful weekend.